All right, overlapping triangles. As you can see, if you only came up with 15 triangles here, you didn't count any of the overlapping triangles. So what we're working on today is overlapping triangles. So how many triangles are here? Not 4. 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, and then 7, 8. Okay, 8 different triangles. So, whoops. Okay. So figure ABCD is parallelogram with diagonals AC and BD. List the corresponding sides of angle BAD, and DCB. Okay? So triangle bad, and triangle DCB. What are the corresponding or overlapping sides of those two triangles that I just outlined? And the answer is BD. BD is congruent to BD. Those are the overlapping sides. When it's the same thing on each side, we're going to use the reflexive property. Okay? Reflexive property. Now, is EGD congruent to is EGD, this angle right here, congruent to EFH, this angle right here? Okay? Are those two angles congruent? And you can say, they look like it, but can we prove it? Well, in these triangles, what do I know? Well, I have a big triangle right here. That's what type of a triangle? Not overlapping yet. Just one big triangle. It's an isosceles triangle, right? Because it has two congruent legs. So it makes this angle congruent to this angle. So then all of a sudden, I have what to make the two outside triangles congruent? To make this triangle congruent to this triangle, I have side angle side. So I start with the isosceles triangle theorem, then I have side angle side. Then, because of side angle side, I can say this angle is congruent to this angle by CP, Okay, those two angles are congruent. And so then these have to be congruent because of the congruent supplements theorem, which we had in the first chapter, which says if you have two supplementary angles that are congruent to two congruent angles, then those supplements have to be congruent to each other. So, yes, we can prove it that those are congruent to each other. It says, write a proof to show that BFE is congruent to CEF. So this triangle right here is congruent to this triangle right here. Why are those two triangles congruent? And what we're given is stuff over here further. Now, back in the day, when I was in high school geometry, this is how we had to do proofs. We didn't have any kind of multiple choice drop downs. We didn't have computers, people. I mean, there was one computer in the whole school type of computers back in the 80s. So we really didn't have computers to use. So we had to do things by hand. So I want to get those two triangles congruent in the end. Okay? So to do it, I need parts congruent. So I know that AB, that's too bad that something went wrong. AB is congruent to DC. AB is congruent to DC. AF is congruent to DE. And angle A is congruent to angle D. Why can I say all of those three things? Because they are all given to us. Then, I can say triangle ABF is congruent to what triangle? Triangle ABF over here is congruent to DCE. It has to be in that order. Order is important. What tells me that? Side angle side. Side angle side says that those are congruent. Then I can say BF is congruent to CE by what? CPCTC. This is congruent to, should make 3 marks, is congruent to this. Okay? I can also say, by CPCTC, that angle AFB is congruent to angle DEC by CPCTC. Okay? So this angle right here is congruent to this angle right here. Okay? Which then in turn makes the angle right across from it, angle CEF, congruent to angle BFE because of the congruent supplements theorem. Okay, now I'm going to redraw these two that are equal to each other, that I want equal to in the end. So E, F, B, E, F, E, C. F, E, C. Now, I know from this step right here, step 3, BF is congruent to CE. I know now all of a sudden angle CEF, this one right here, is congruent to BFE, this one right here. Is there any way to say FE would be congruent to FE? Is FE congruent to FE? It definitely is. What's the reason that FE is congruent to FE? When they're the exact same thing, it's called the reflexive property. Do I have enough to say those triangles are congruent? Can I say triangle BFE is congruent to triangle CEF? Yeah, because of what? Side angle side again, side angle side. So that's how to work with overlapping triangles. All right, so for triangle, this triangle here to be congruent to this triangle here, what I should do is I should just draw them separately. And you'll see how much that helps the whole process. So ACD, and then CBE. Okay, I know that CD has 2 marks and CB has 2 marks, right? I know that angle A has 1 mark and angle E has 1 mark. What can I say about angle C in each of them? What can I say about angle C and angle C? They're congruent. Why? They are reflexive. They are overlapping. They are the same thing. When they have overlapping parts in the same thing, they're congruent to each other. Are these 2 triangles congruent? By what? Not angle side angle. What do you think? Abby Jones, what do you think? Angle side. Exactly. Angle side. All right. We're going to skip over this one. It's kind of neat, but it's just like, I don't think so. So what we're doing is overlapping triangles. And when you have overlapping triangles, like in this case, these two triangles are congruent by side angle or side because KM is congruent to KM. These two triangles are congruent by side because LJ is congruent to LJ. Okay? So you can use overlapping parts to make things congruent. Here, angle B is congruent to itself. So by angle side angle or angle side, then we can prove triangles congruent. And then we can use hypotenuse leg to help us prove triangles congruent. So when you have overlapping parts, the parts that overlap each other are important. And on today's exercises, some of your things, all it'll ask you for is, what is the overlapping part? And you just got to tell me, what's the overlapping part? Okay? So that's it for that. We will only have one quiz over this stuff, and it won't be over the overlapping parts stuff, but it'll be over what we did in the first one, the HL theorem. That will be on Wednesday, and then we'll take the practice test Wednesday.